Hi, in this lesson, we're going to continue to talk about parametric tricks and parametric curves and graphs. Last time we did an example, which is a circle, and we have seen that for a function, for a parametric equation like this, right? We get a curve, which is counterclockwise as time increases, and counterclockwise we get the points on the circle, and it goes like this, starting at 0 and counterclockwise, and it goes in this direction. And after 2 pi, it goes to another circle. So if you imagine there's a particle like going around each second at a certain speed in the amount of 2 pi seconds or minutes or hours, is going at this rate, going at this rate. It go about the circle just around and round. So that would be the trajectory. Okay. And in this example, I'm going to, in this lesson, I'm going to show you another example. Okay. This second example, actually, I will call example number 4. Okay. Example number 4. Example number 4 is almost the same as the one in example 3. The only difference is I have 2 times t. Okay, so what will happen? What's going to happen, right? What will be if there's a particle that go about the trajectory mapped by x and y? What is going to be the consequence, right? What will be the trajectory? What will be the curve? So that's what we're going to go about. What's the difference between this one and the one we did earlier? So first of all, if we convert it to a rectangular form, if we get rid of the t, right? If we eliminate the parameter, if we eliminate the parameter t, we will get cosine squared of 2t plus sine squared of 2t equals to 1, right? And that is the same as y squared plus x squared equals 1. It is still a unit circle. There's still a unit circle. But what? So if a particle goes about the unit circle, is this the same as the previous circle? We are going to have the circle, but when we plot the points, there are going to be some differences. Okay, so I'm going to put this original table on the side. Hold on, let me copy that table. Okay, I'm going to show you how we would choose the points. Okay, just like that. Okay, so I'm going to show you the difference for the new function, right? So this is going to be 2t, and this is going to be 2t. Okay, a lot of these points, we're gonna select points differently. We're gonna select points very differently. So I'm gonna remove all of that. Okay, I copy these 2 tables just to show you there are some similarities, so you can see the difference. Okay, of course, the circle has to be redone. I'm going to put it on the side. Okay, so y equals to 0. So we're gonna have a unit circle for sure, but we're gonna see how the points is gained, okay? And of course, we're gonna have to choose different inputs, right? Just a second, okay? Just give me a little more time for me to complete this rectangular system. And 1.1, okay? So that's the new rectangular system. We expect a unit circle, but this time I'm gonna choose points. Okay, this is how I'm gonna choose the points, okay? 0 is gonna be the same, okay? And pi over 6, I'm gonna choose it to be half of it, okay? Half of it. So half of it and half of it. Okay, you can see instead of choosing 30 degree, I'm choosing 15 degree. Okay, so why do I choose this way? And you're going to find out very soon. For 0, there's no difference, right? 2 times 0 is going to be 0. And that's going to be cosine 0. Cosine 0 equals 1. 2 times 0 is going to be sine. I'm going to put a parentheses just to avoid any confusion. So this is going to be 0. So the first point is going to be the same, 1, 0. So at a time 0, the particle is going to be right there, the same spot as it was before, okay? But at half of pi over 6, okay? And I'm going to calculate the x and y. Since t equals to half of pi over 6, so this t is going to be replaced by half of pi over 6. So this way, 2 times half times pi over 6, and this is going to be equals to cosine pi over 6. So do you see that? So this algebraic manipulation, I choose points accordingly, and this is going to cause cosine pi over 6 at time equals to half of pi over 6. Okay, you think of that amount of time has passed, and that's going to be root 3 over 2. Okay, and the other one for 2t, right? T is equals to half of pi over 6, and that's going to be sine of pi over 6. You clearly see what I have done here, right? What I have done here, and this is going to be equals to half. Okay, so the next point is still root 3 over 2, comma half. If I put that point on the graph, you're going to see comparatively, there. Okay. Let me just make sure they look comparable, right? They look comparable. This dot, so these 2 spots, okay, they're at the same spot, okay? But how much time it takes to, you see, this piece, right? When t equals to, let me make it just a little smaller, okay? When t equals to half of pi over 6, it reaches the same point. It reaches the same point as when t equals to pi over 6. So it takes half time for the particle to get from one place to the same place, right? So see, in our previous function, cosine t, sine t for x and y respectively, it takes pi over 6 amount of time for the particle to move this much of arc. But for this latter one, cosine 2t, sine 2t, it takes half the time. Okay, it takes half the time. To make that comparison, so let me put it over here. So that's what I want you to, that's what I wish to show you, right? So these two pictures right here, right? And I will bring the previous table over here. Okay, I'll bring the previous table. That's gonna be hard to make that table. Hold on, I'm sure I can do it. There, I'm gonna make it 50%, so this way I can copy and paste the whole thing. Okay, right there. And this is going to be, say, 125%. So what I want to show you, right, is that this is the particle, like move about. Wait, where's my other table? Oh, here. I want these tables to lie next, side by side. Okay, so now it's side by side. Okay. So now the two unit circles are lined side by side. How much time does it take for the previous one, example 3, from 0, the amount of time that take this particle to go from time 0, right, to pi over 6, how much time it takes to get there? It takes pi over 6. Okay, that's how much time it takes. For this latter one, it takes half of pi over 6. So what this means is that a particle follow the trajectory in example 4 is twice as fast as the one in example 3. So that 2t makes that difference. It makes that difference. And other than that, everything is going to be very, very similar. So the way we're going to choose the points, okay, the way we're going to choose the points is going to be half the time we're going to reach the same points, okay? So for pi over 4, pi over 2, I'm going to choose half of it. Half of it. And now this is going to be half of it. Half of it. So by the time we get to pi, we have already finished the entire cycle, cycle in example number 3. Okay, so that will be the calculation. Okay, so where's my, yeah, half of pi. By the time we're half of pi, right, it has already reached to, well, it takes pi over 4 to get to this place, but it takes pi over 4 for this other one to reach this point. Okay, so this latter example particle that travel on this trajectory of example number 4 is twice as fast. Okay, so let's look at a few more examples to explain to you what I meant. Okay, so now with half of pi over 4, I'm going to put this, the amount of time in the function, in the parametric function, and this is going to be equals to cosine pi over 4, okay, cosine pi over 4, And that's going to be equals to root 2 over 2. Okay, and for this other one, and that's going to be sine of pi over 4. That equals to root 2 over 2. In other words, in this latter example, in the parametric equation, in example number 4, it takes half the time to get the same spot as the one we did earlier. Therefore, the point we get here to reach pi over 4, okay, so root 2 over 2 to reach this point, we takes half time to get there. It takes half time to get there. So if we put the point in on the unit circle, so that's where we're getting. Okay, so the trajectory is going to be the same, but the latter one is twice as fast. It's twice as fast. Okay, so let's follow this to do the half circle, right? To do the half circle. So next we're going to do half of pi over 3. Half of pi over 3. Okay. If you could do it with me, that would be great. Okay. Pi over 3. So this is pi over 3. So this is going to be half. And this is pi over 3. And this is pi over 3. This is root 3 over 2. So the next point is half. But takes half the time to get there. And root 3 over 2. Okay. So we're going to show you that it takes much less time to take half the time to get where we used to be. Okay, so this is going to be cosine pi over 2. That equals to 0. And the next one, y is equals to, this is pi over 2. So this is pi over 2, and that equals to 1. So that point is 0, 1. 0, 1. So this point is going to be right there. Right there. You see, it takes pi over 4. Take the amount of time of pi over 4. Half time pi over 2 is pi over 4. To reach the point right here, it takes pi over 2, right, which is over here, to get to the same spot in example number 3. That is the difference. Okay. If we finish up the rest, okay, I would like you guys to finish up the rest along with me, but only going to up to pi. Okay, we're going to finish. I'm going to leave the rest of you for your homework. You know, for your homework. So in class, we're just going to do half of it. Okay, we're just going to do it up to pi, and you can see we'll finish a full circle. We only do it up to here. Okay, so we have a few more to go. Okay, we have a few more to go. So let's go. Feel free. I'm going to make some changes. Okay, I'm going to make some changes. Okay, so pi over 2, we have done pi over 2. This is a 2 pi over 3. So 2 pi over 3. So this is going to be 2 pi over 3. 2 pi, cosine 2 pi over 3 is negative half. Okay, so this is a 2 pi over 3. Okay, 2 pi over 3. And that's going to be root 3 over 2. Okay, and where would this be? This point is going to be negative half, comma, root 3 over 2. Root 3 over 2. And that point is going to be right there. Oops. Yeah. Wait. Did I get that? I'm going to. Oh. Wait. Yeah, that's the point. Okay, how did I get that y equals 0? Let's make it going to be black. So that's back where it was. Okay. So keep going. 3 pi over 2. 3 pi over 2. So that's going to be 3 pi over 2 here. 3 pi over 2. And that's going to be negative root 3. 3 pi over 2. 3 pi over 2. And that is going to be negative root 2 over 2. And that is going to be positive root 2 over 2. Okay, it takes a lot of patience, don't you see? Okay, so that's going to be negative root 2 over 2. And the other one would be root 2 over 2. Okay, so we have a point right there. On the unit circle. Okay. It takes half the time. It takes half the time. And this next one, 5 pi over 6. Right? 5 pi over 6. 5 pi over 6. 5 pi over 6. And 5 pi over 6. You can see the choice of numbers. Cosine 5 pi over 6 is negative root 3 over 2. Okay. And this other one is going to be half. Okay, so that point is going to be negative root 3 over 2 and half. Okay, and that point, of course, has a place on the unit circle. All right, and then we get to 7 pi over 6. Wait, half of pi. Okay, so this is half of pi. So here is going to be pi, and this is going to be pi. This is going to be pi, and this is going to be pi. So this is going to be -1, and that's going to be 0. Okay, so -1, 0. So now let's compare. Okay, in half pi's time, okay, in half pi's time, we have gone this far. We've gone pi. Okay, the arc of pi. For this one, half pi's time, with half pi's time, where were we? We were at just 0.1. Okay, so now you can see the difference. You can see the difference, right? So once again, it demonstrated that the trajectory in example 4 and the trajectory in example 3, the particles on each one travel at different speed. One is, in example 3, is twice as slow. Okay. And for the remainder of the time, okay, for the remainder of the tables, okay, I want you guys to write this down, maybe pause to write it down, because I'm going to put this as for your homework. Okay, so this is how to graph the units, this kind of parametric, and you can mark the direction. And of course, there's a unit circle here, right? One is 1 minus x squared. Okay, that's a half circle, right? So in pi over 4's time, right? Half the time, pi over 4. Okay, pi over 4's time. That's pi over 4's time. We have traveled a quarter, right? In half of pi's time, we've traveled this much in example 4, and in half pi's time, we only traveled a quarter of the circle. Okay, so I hope that's very clear to you. If you have any questions, please don't hesitate to reach out to me. So to finish the rest of the half circle, okay, which is going to be, that's going to be taking half the time as well. There we go. It's very similar, so I'm going to leave that part for you. Okay, and so this is for your homework. Okay, so that piece is for your homework. Okay, now next we're going to do something different. We're going to be doing something different. Okay, this will be another example in your homework. Okay, this will be another example in your homework, but this time, okay, you're going to see both the algebraic skill. So I'm going to call this example number 5. Okay, so this is how it goes. Okay, so this time we have x equals to 2 rows, wait, 1 column, 2 rows. Okay, we have a parameter t, and x is equals to 3 times sine of t, and y is equals to 5 times cosine of t. Oops, cosine of t. Okay, so now let's see how we're going to graph this one, right? First, let's eliminate t. How do we eliminate t, right? So this is how we're going to eliminate t. We're still going to use sine squared plus cosine squared equals to 1, right? So from this form, we got sine of t is equals to x over 3. x over 3. We can make the fonts larger. Okay, and from the second one, we're getting cosine t equals to y over 5. And then we're going to apply sine squared t plus cosine squared t equals to 1, right? So then we're going to replace sine t by its equal, which is x over 3 squared plus y over 5 squared equals to 1. Then you wonder, what kind of curve would this be? X squared over 3 squared. Oops. Not 3 to the power 3, 3 to the power 2 plus y squared over 5 squared. 5 squared. You wonder, what kind of curve is this, right? Well, some of you may recognize this is an ellipse. This is ellipse. Okay, but what kind of ellipse is that? Okay, ellipse. So let's graph it. Okay, so we got the equation after eliminating t. So let's graph the function. Let's graph the function. So to graph this function, of course, we're going to set a table. Okay, with number of rows, right? And here, of course, we have t. So you really experience how, parametric equations can produce graph. Parametric equation produces graph. Okay, and then our point, x comma y. Okay, so let's get started. And t is a time that increases starting from 0, right? Starting from 0, but how do we choose our points? And of course, we're going to choose our special values, right? So these special values we're going to choose, and I'm going to borrow 1, 2, 3, 4, 5. You probably already guessed it. We're going to just use these special values on this unit circle that we have chosen before. 1, 2, 3, 4, 5. There. And we would continue, right? We would continue. Let's see, how many rows do we need, right? So we're going to add some more rows, right? So from 2 pi over 3, we're going to continue 1, 2, 3, 4, 5, 6, another 6, 1, 2, 3, 4, 5, 6. Oops, sorry. 1, 2, 3, 4, 5, 6. It's a process. Let's see how many. I think we have just a couple more. Okay, I'm being kind of lazy. 1, 2, 3, 4, 5. 4 pi over 3. Is that where we were? 4 pi over 3. So I do want you to see the similarity. 1, 2, 3, 4, 5. There you go. Okay, then you just do 1 point at a time. 1 point at a time. Okay, so I'm going to set up the rectangular system. And this time we don't know what we're getting. Okay, we'll pretend. Some of you probably may not know about ellipse. So we're going to do it according to satisfy, everybody's need. And therefore, I'm going to just, we're just going to do some points together. Okay, so be patient with me. Have your paper pencil ready for you with you. Okay, have your paper pencil ready. And we're going to see for 0, for x equals 0, right? So t equals 0. So that piece is equals 0 and t equals to 0. That's going to be cosine 0 is 1. 1 times 5 is 5. So the first point is 0, 5. Okay, so at time 0, it's 0, 5. Where's 0, 5? Well, there's a 0, 5, right? Right there. So that's the starting point at time 0. And we just keep going. We just keep going. Okay, at pi over 6. Pi over 6. Right? So you just put the points in place. Pi over 6 is half. Half times 3 is 3/2. Okay, cotangent pi over 6 is root 3 over 2. So you're going to have 5 times root 3 over 2, right? So put the 5 on the top. There you go. So you get a point and you see where that point goes, right? This is x and that is y. You can see that there's no fundamental difference in terms of the way we do it, right? So the next point is going, oops, we're going this way. Where does it go? It's going this way, right? That's the direction. This is the starting point. And we keep going. Oops. Okay, pi over 4. So at time of pi over 4, this piece is going to be 3 times root 2 over 2. So 3 times root 2 over 2. And that one equals to 5 times root 2 over 2. Okay, so we get another point. And the x equals to 3 times root 2 over 2. And y equals to 5 times root 2 over 2. And you put that point on the graph. Obviously, this time we're going clockwise, right? We're going clockwise. So that's the point, right? So you can see, let me make some pointers so you know where we are. So first point, second point, and third point. So we're going to go one at a time, point by point, point by point, okay? All right, pi over 3. Oops. Pi over 3. So let me just make a few more copies of these things. If you like, you can pause and come back to compare okay. And the last 2 rows. We'll see if we have the patience to do all of it. Okay. Now we already have a roughly what to expect, right? So let's continue. Pi over 3. Pi over 3. And that equals to sine pi over 3 is root 3 over 2. So 3 times root 3 over 2. And cosine pi over 3, what does that equal to? Cosine pi over 3 is half, right? 5 times half is 5/2. So we got another point. 3 times root 3 over 2, comma, 5/2. So we get another point. So to put this point on the graph, it's coming down, it's coming down. Let's see where we are going to be at pi over 2, right? So at pi over 2, okay, wait. T is pi over 2. I better save the file in case I, make a mistake by accident. Sine pi over 2 is 1, so this is equals to 3. Cosine pi over 2 is 0, so this is just 0. So the next point is 3, comma 0. So if you know this is a, okay, let me just put the points in place. And this is the ellipse, right? So the ellipse is going to be like this, symmetrical. Okay, symmetrical in 2 directions, about the y-axis and about the x-axis. So already have a quarter. So the direction goes like this. Oops. Okay, so here's the direction. Keep going. Okay. If there's a particle travel on this curve and this is the direction it goes, starting from 0,5, it goes that way. Okay, clockwise. Okay. All right, so we already have a glimpse of what we are getting. The next is that we have the patience to finish the calculation. Okay, so let's do it together. Okay, these will will give you the experience. Okay, sine 2 pi over 3. What is sine 2 pi over 3? It's root 3 over 2, right? So 3 times root 3 over 2. And cosine 2 pi over 3 is -1/2. So this is going to be -5/2. So the point is going to be 3 times root 3 over 2 and -5 over 2. And that point is going to be, where do you think it's going to be? In the 4th quadrant, right? In the 4th quadrant. So right there. So we keep going. So we have a few more points, right? Now it's the 3 pi over 4. So we plug in. You can see the process is very predictable. It's very predictable. Sine 3 pi over 4 is root 2 over 2. So this is going to give us 3 times root 2 over 2. You can put a unit circle by your side. Cosine 3 pi over 4 is negative. So 5 times negative. So -5 times root 2 over 2. And we got a point here. Right, you can just have the calculator does the approximation. And the way I express these points are usually preferred by your future professors. And here you go, right? Let's keep going. Okay, we have 2 more points by the time we get pi, right? So 5 pi over 6. Well, it takes just patience. And over here, sine 5 pi over 6 is half. So this is going to be 3/2. And cosine 5 pi over 6 is a negative, right? 5 times root 3 over 2. 5 times root 3 over 2. So by this time, we get another point, okay? The y and the x. There we go. I'm going to put the point on the graph. there. Okay, so we already see half of the ellipse, half of the ellipse. The next point is this is going to be pi. So we get sine pi is 0, so this is going to be 0, and this over here is going to be -5 because cosine pi is -1, and so that's that at time pi, the particle reaches the point of 0, -5. So we're going to put the point in the graph right there. Boom. Right, so half of the ellipse is already there. Okay, so let us continue. Right, to finish the rest of it. And this will be the perfect opportunity to review your trigonometry. Okay, and over here, sine 7 pi over 6, that's going to be -½ so -3/2, and cosine 7 pi over 6, that's a negative, right? And that's going to be √3/2, so 5 times √3/2. And here we go, we got another point. Okay, so -½ -5 times √3/2. I'm going to put it on the graph. Right, the point is in the third quadrant. Shall we do this one by one? Let's see how many we have left. Oh, we're almost there, right? It's just two more quadrant, and then we get there. Okay, so this is both are negative in this quadrant. So we get -3 times √2/2. And this one equals to -5 times √2/2. So the point is going to be -3 times √2/2, comma, -5 times √2/2. And we got another point. Okay, don't give up. You can do it. Okay, you can do it. We are almost there. So the next point is 4 pi over 3. Okay, 4 pi over 3. If you want to focus on doing these points, right? So let's do these two, right? In the third quadrant, and then we continue. And this is going to be -3 times √2/2. And that is going to be equals to -5 times √2/2. So -3 times √2/2, -5 times √2/2. 3 pi over 2, that's going to be equals to -3, right? Because sine of 3 pi over 2 is -1. Cosine of 3 pi over 2, that's a 0. So we get another point. So this time we do 2 points at a time. Okay. So let's see, where do we put them? So we have this point. Right? And one more point, -3, 0. We are almost done, right? -3, 0, right there. So you can see the ellipse is almost there. Okay. And next, we have 5 pi over 3, 5 pi over 3, 7 pi over 4, 7 pi over 4. We really just have three points to work with, because for 2 pi, it's going to be the same value, right? At 0. Okay, so let's finish it. 3 times sine 5 pi over 3. Sine 5 pi over 3 is negative root 3 over 2, right? So that's going to be negative 3 times root 3 over 2. And over here, cosine, that's going to be half. Okay, so that's going to be 5 half. Right, because in the fourth quadrant, cosine is positive. So we have negative 3 times root 3 over 2 and 5 half. And this one over here, that's going to be negative. In the first quadrant, sine is negative. Okay, so that's 2. Cosine here in this quadrant is positive, first quadrant. So root 2 over 2. We got another point. You see, with patience, we obtain all things. 5 times root 2 over 2. We haven't plotted these points yet, okay? And this one, that's going to be negative half times 3. That's going to be negative 3 half. Right, that's going to be negative half. And over here, that's going to be positive. Okay, so 5 times root 3 over 2, where we are almost there. Okay, negative 3 half. And 5 times root 3 over 2. Okay, so we have these 3 points to plot. This one, right there. Do we get to see that point? Wait, where's that point? Negative 3 times root. Wait, what did I do? Did I do anything wrong? Oh, you know, it should be red dot. There we go, right? And the next one over here. I keep telling myself not to rush, because if I rush, I may just have to spend more time on it, right? One more point. There. Okay, so the last point, what will be the last point? It should overlap with the existing point, right? So that's 2 pi. Okay, and this piece is 0. And this is 2 pi. And that should be 5, right? So that's 0, 5. One full cycle, but the trajectory goes like this, okay? So if we are to mark the directions, so it goes like this. Okay, so that's the ellipse. That's the ellipse. Okay, so if I if I connect the dots, right, on the curve, what do I get? If I connect the curve on the dot, how would I come up with this, right? I would take this, okay? So I'm going to use that by solving for y. Okay, solving for y. So I'm going to subtract this piece on both sides. Okay. And multiply by 5. I mean, taking square root on both sides. And then the left-hand side is going to be, oops. The left-hand side is going to be absolute value of y. Okay, divide by 5, if you wish, equals to the right-hand side. Okay, and then further, okay, y would be equals to plus or minus 5 times that piece. Okay, so we have 2 pieces to graph to get the curve. Okay, so I'm going to graph these 2. One is negative and the other one is positive. There you go. And the curve particle starting from 0, right? If you make a complete graph, it's going like this. That's it. That's it. Okay, there's some other examples in your homework for you to practice, right? So this will be the perfect opportunity, 1, to understand parametric, and secondly, to review trigonometry. Okay, I hope you guys would, take your time to work on these examples. And until next time, thank you for watching.